I'm going to show you my simplified equation that I use to get through all of my med math. Hey everyone, I'm Steve, paramedic instructor coordinator. And today we're going to try to make med math a little less scary. I'm going to show you my simplified equation that I use as my base to get through all of my med math. Before we get into the nuts and bolts of doing med math, we got to talk about the metric system. The metric system is based on multiples of 10, which is actually great because we can use this to our advantage, but we'll get to that in just a bit. Before we get too deep into it, we need to talk about the names of our units. You see, the metric system uses a prefix and root word system that relates to not only the size, but what's being measured. We have 3 root words or base units that we use to describe not only the object, but how we're measuring them. These base units are meter, which equals distance, liter, which equals volume, and gram, which relates to weight. Let's talk our prefixes. These are what relate to that multiple of 10. Starting from larger to smaller, we have kilo, hecto, deca, and base unit, or our root word. We then have deci, centi, milli, and then we need to talk about way down the line, microgram. This can all be a little difficult to remember, so we'll make it easier in just a bit. But for now, let's stick with the whole metric family. Because the metric system is based on multiples of 10, each prefix represents a decimal place. So if we're moving from one prefix to another, we can count how many prefixes are in between, and that will equal how many decimal places we need to move. To help make this simple, we'll keep our list from big to small. To convert from larger to smaller, we're going to move our decimal place the amount of prefixes to the right, because we're moving from left to right. To convert from a smaller unit to a larger unit, we're going to move our decimal place to the left. For example, if I have 2 grams and I want to go to kilograms, I'll move the decimal place 1, 2, 3 and get 0.002 kilograms. Now all the prefixes are equal to 10 and represent movement of 1 decimal place, except for micrograms. That one is actually going to be equal to 3 additional decimal place movements. But don't worry, that will actually help us when we break it down to make it a little bit easier. Alright, let's make it easier. In medicine, for the most part, the only prefixes that we tend to use are kilo, base unit, milli, and micro. It just so happens that all of these prefixes are 3 decimal places apart. So instead of remembering all of the prefixes, I can just remember those 4 and move my decimal place not once, but 3 times for each prefix. To remember these 4 units, I like to use the mnemonic killed by med math. Kilo, base, milli, micro. Now all weight-based medications are going to need the patient's weight in kilograms. Most of our patients are going to give you their weight in pounds, so we'll need to know how to convert from pounds to kilograms. But this is pretty simple. Just take the pounds that the patient gives you and divide it by 2.2. This will give you kilograms. Now you can do this conversion in your head by dividing the number in half and subtracting 10%. But I find people tend to forget to subtract that 10% and only divide by half, and this will skew your entire med math equation. Let's go over a few terms so we're speaking the same language. Desired dose is going to be what you want. It's going to be what's written in the protocol or maybe on the medication orders. If the medication is weight-based, it will look something like this. And you're going to need to multiply the desired dose by the patient's weight in kilograms. For our other terms, we're going to need to look at our medication. If you take a look at a medication vial, the medication concentration is the medication weight over the medication volume. For liquid medications, the volume is going to be in milliliters. For tablets or pills, I like to think of the volume being 1 pill or tablet. For example, with acetaminophen tablets, my concentration would be 160 milligrams per 1 tablet. So the volume would be 1 tablet, and the medication weight would be 160 milligrams. For a liquid medication, we'll say fentanyl, this comes in 100 micrograms as the weight over 1 milliliter, which is the volume. Now, the method I'm going to show you works for me. It may not work for you. It doesn't matter how you get from A to B, as long as you get there correctly. If you have a way to do med math that works for you, stick with it. So here's my super simplified med math equation. We're going to take the desired dose and multiply it by the patient's weight in kilograms if needed. Now remember, that's only if the medication is weight-based. We'll then divide this number by the medication weight found on the vial with the medication concentration, or right here. We'll then multiply by the medication volume. This will give you the amount of volume you need to administer. So if this was a liquid medication and I was drawing this up into a syringe, this would give me the milliliters that I need to administer. Again, I can change out my milliliter volume for tablet if I'm using pills or tablets, and this will give me the amount of tablets I need to administer my patient. Let's go over a few practice problems together. So for our first example, this one's pretty easy. We're going to do the med math for an IM epinephrine injection. So what we have here is a desired dose of 0.3 milligrams of epinephrine, and it's supplied in 1 milligram over 1 milliliter. We have our equation here off to the right. So we're going to take our desired dose, 0.3 milligrams, and we're going to divide that by 1 milligram, which is our medication weight. This is going to give us 0.3. We're going to multiply that by the medication volume, which is 1 milliliter, and this is going to give us 0.3 milliliters. So, nice easy one to start out with. For our second example, we have a weight-based drug. Our desired dose is 0.25 milligrams per kilogram. Our medication is going to be supplied in a 5 milligram and 2 milliliter vial, and our patient weighs 50 pounds. So go ahead and try the math, and we'll go through this together. Alright, so first let's start out with our patient weight. So our patient weighs 50 pounds. We're going to divide that by 2.2 to get 22.73 kilograms. We're going to multiply 22.73 kilograms by 0.25 milligrams from our desired dose, and we're going to divide that by our medication weight, which is 5 milligrams. This is going to give us 5.68 over 5 milligrams. We'll divide that, it'll give us 1.14, and we'll multiply this by our medication volume, which is 2 milliliters, and this will give us 2.3 milliliters as our amount to give our patient. So here's our third example. Our desired dose is 0.03 micrograms per kilogram. It's going to be supplied in an 8 milligram in 250 mLs, and our patient weighs 175 pounds. So let's start out with the patient weight. 175 pounds divided by 2.2 is 79.5 kilograms. 79.5 kilograms multiplied by 0.03 micrograms over 8 milligrams. Now this won't work. We need to make sure our units match. So we're going to have to convert our 8 milligrams into micrograms. Let's use our little mnemonic, killed by med math. We're going from milligrams to micrograms. So we're going to move our decimal place to the right 3 spaces. So 8 milligrams, 1, 2, 3. And that's going to give us 8,000 micrograms. So let's rewrite our equation. We have 79.5 kilograms multiplied by 0.03 micrograms over 8,000 micrograms. This gives us 2.4 micrograms over 8,000 micrograms. Divide those, and our answer is 0.003. We'll multiply that by our medication volume, which is 250 milliliters, and this will give us 0.003 0.075 milliliters. Alright guys, thanks for joining me. I hope this video helped make MedMath a little less confusing. If you have any questions, please reach out. Thanks.